Alright, in this video we're going to be looking at component form of a vector, and really we're going to be using component form the rest of the time with vectors, and we'll be doing some algebraic operations with vectors, but we're going to make sure everything's in component form in order to do that. Now, what is component form? So we have looked at vectors geometrically. We know that we have an initial point P, and then we've got terminal point Q. Alright, what component form is really, you've got to think about it as, how do I get from that initial point to that terminal point? Well, if I was going from P to Q, I would go over horizontally, and then I would go up vertically. Alright, well, what is the length of that horizontal distance going to be? Well, that's going to be the difference in your x value. So that's the change in x. So that's just going to be x2 minus x1. And then that vertical length, that's going to be the horizontal component, or y2 minus y1, the change in y. Alright, now notice that I have A1 and A2 written here. That's just the book notation. Also, I don't want to be writing x2 minus x1, y2 minus y1 every time. Alright, so understand that this is the notation the book uses, and that A1 is our horizontal component, or the change in x. A2 is our vertical component, or our change in y. Alright, so this is A1, A2. Now, if I am looking for the magnitude, remember the magnitude is the length of the vector, the length of the vector. Well, if I'm given the horizontal component and I'm given the vertical component, how would I find the length of this vector? Well, I would use the Pythagorean theorem, because this is a right triangle, and I know that A1 squared plus A2 squared equals the length of this vector squared. So I would take the square root of A1 squared plus A2 squared, and that would give me the magnitude. Alright, so let's do some exercises with this. Alright, so the first exercise example says express the vector with initial point P and terminal point Q in component form. Alright, so let's do that just by, let's call this U. Alright, remember that our horizontal component is the change in x. So here's x1, y1, x2, y2. So we've got 4 minus 1. And then we've got the change in y, which is 5 minus 3. Also note, and I didn't mention this earlier, but the notation for component form is these brackets. Alright, so component form of this particular vector is going to be 3, 2. And I want us to look at that so you really understand what's going on here. So let me draw it out. Alright, if I'd ask you to sketch the vector PQ, you would have started at our initial point, which is 1, 3. And then we would have graphed our, would have gone to our terminal point, which is 4, 5. So we had this vector right there. Alright, so component form means that I'm looking at the horizontal component and the vertical component. So my horizontal component was 3, my vertical component was 2. And you can see that because my initial point I went over 3 and then up 2. Alright, let's do another one. It says sketch representations of the given vector with initial points at 0, 0, 2, 3, and negative 3, 5. And then they give me this vector in component form. It's negative 7, 2. Alright, so I'm going to start at 0, 0. Component form, this is my horizontal component. This is my vertical component. So if I'm starting my initial point at 0, 0, I'm going to the left 7, 1, 2, 3, 4, 5, 6, 7, and up 2. So my vector is starting at 0, 0, and it's got a horizontal component of negative 7 and a vertical component at 2. Now, I could have also started my vector at 2, 3. So here is 2, 3, my initial point there. I'm going over 7, so 1, 2, 3, 4, 5, 6, 7, and up 2, 1, 2. Alright, now let's do the last one. We want to start it. Our initial point is at negative 3, 5. So I've got negative 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5. So I'm going to start right here. And then I'm going over 7, 1, 2, 3, 4, 5, 6, 7, up 2. So I have another vector right there. Okay, so you'll see by this that the vectors, I could start them anywhere in the plane. For our purposes, you're going to probably start them at the origin at 0, 0. But notice that this has 3 different representations of the same vector. These are all equal vectors. Alright, let's keep going. This one says, sketch the given vector with the initial point 4, 3 and find the terminal point given component form. Alright, so let's sketch it and just check it out. Alright, so my initial point is at 4, 3. And then I know component form, I've got horizontal component at 4, so I'm going over 4. And then 1, 2, 3, 4, and then I'm going down 3, 1, 2, 3. Alright, so this component gave me my horizontal component and my vertical component. It gave me the initial point, and you can see that it says to find the terminal point. Well, the terminal point, just by sketching it and looking at the graph, is at 1, 2, 3, 4, 5, 6, 7, 8, 8, 0. Alright, so we're saying that Q is at 8, 0. What's another way I could have done this? There's another way I could have done this algebraically, because I know that the change in X equals that horizontal component, and I know the change in Y equals that vertical component. So you also know that x2 minus 4 has to equal 4, and y2 minus 3 has to equal negative 3. Alright, if I solve these, I get x2 equals 8. I get y2 equals 0. So I could have done that algebraically as well, but it asked me to sketch the graph, so I drew it so you could see it.